Here, a weight attached to the end of a long spring is bouncing up and down. As it bounces, the distance from the floor varies sinusoidally with time. You start a stopwatch. When the stopwatch reads 0.3 seconds, the weight first reaches a high point, 60 centimeters above the floor. The next low point, 40 centimeters above the floor, occurs at 1.8 seconds. Part A asks to sketch a graph of the sinusoidal function and write an equation expressing distance from the floor in terms of the number of seconds the stopwatch reads. It also asks to use a cosine function. Part B asks to predict the distance from the floor when the stopwatch reads 17.2 seconds.
So first, we can start by graphing by plotting down the y-axis from 10 to 60 with increments of 10, and then the x-axis from 0.3 to 3.3 with increments of 0.3. And using the information from the problem, we can graph that 0.360 and 1.840. And to get the point in between that, we add both of the x values and divide over 2, and then both the y values and divide over 2. So then we get 1.05 and 50. And to get the next highest point, we subtract 1.8 and 0.3, which is 1.5, and then add 1.5 to 1.8, in which we get 3.3. So we can graph 3.360. And to calculate the period, the equation is 2 pi over b. So the distance in between is 3.3 minus 0.3, which is 3. So then we can plug that into the equation and solve that the period is 2 pi over 3. And to calculate the amplitude, the equation is the maximum y value minus the minimum y value over 2. So 60 minus 40 over 2 equals to 10. And there's a phase shift of 0.3 to the right. And we can also identify that the space in between the two highest points is 3, and that there's a vertical shift of 50 since 60 minus 10 equals to 50. So then when we create the final equation, it's 10 cosine times 2 pi over 3 times x minus 0.3 plus 50. And the 10 would be the amplitude, the 2 pi over 3 is the period, the phase shift is 0.3, and the vertical shift is 50.
The formula from part A is y equals 10 cosine 2 pi over 3 times x minus 0.3 plus 50. Part B wants you to find the distance when the stopwatch reads 17.2 seconds. X equals 17.2. So y equals 10 cosine 2 pi over 3 times 17.2 minus 0.3 plus 50. 0.3 gets subtracted from 17.2, and 16.9 times 2 pi over 3 equals 33.8 pi. The new equation is now y equals 10 cosine 33.8 pi over 3 plus 50. Plug the equation into the calculator with mode set to radians. Therefore, the answer is 43.3 centimeters.